This morning I talked about strings, so just the most basic stuff, and then we had the string exercises. So the plan for the rest of the day is I want to talk about lists and tuples, some other data structures, and we'll have a set of little exercises about that. And then I'll finish off talking about dictionaries and files, and hash tables, and then we'll have a large exercise, and that'll complete the day. So that's the plan for today. Probably get you out of here around, I don't know, 4:15, something like that. All right, so let's talk about another Python type. So I'll just fire up the interpreter here. So I did strings. So the next type I want to show you is the list. So the list is appears in square brackets. So if I wanted a list of like the numbers 1, 2, 3, that would look like that. Or maybe I could sign it into a variable to make it very much like my last example. The elements in a list, very often they're all the same type, but there's no requirement. So I could have like 1, 2, and then like a. Oops. OK. What's the problem? Oh, too many commas. Sorry. So you have a list of different types. In reality, mostly you'll have a list of all the same thing for just it's just sort of the most intuitive case. Now Python has this sort of design idea that instead of having one syntax for strings and another syntax for lists and whatever, Python tries to use the one syntax very consistently for all things. And so this is a nice quality. It means when you're learning it, there's less to memorize. So for example, the length function for lists is just the one we learned before. So yeah, I could say len of a, just like for strings. And in fact, many of the bits of syntax or operations for strings work on lists as well. And so Python is sort of deliberately consistent. So for example, I could do a plus. So I could say, well, I have the list 1, 2, AAA, plus the list, what is I guess 3, 4. And like with strings, we've seen that, right? It puts it together to make a bigger string. With lists, it like puts them together to make a bigger list. So one difference that lists have here, I'll set this back to be 1, 2, 3. Is what does the equals do? So if I say B is equal to A, and the key thing to remember here is this does not make a copy. What this has done is there's this one list sitting in memory somewhere, and it used to be that A was pointing to it, and now B is pointing to that same list. So there's one list, and they're both pointing to it. The way you could tell, right? We do a little experiment. Oh, I'm sorry. I didn't really talk about how do you refer to an element inside of here. Yeah, it's just like in string. So if I say a square bracket 0, that's the first element, whatever. So I can check my experiment by using this on the right-hand side. I'll say, well, I'll set a0 to 13. I'm going to change that first element. Lists are mutable. You can change them, unlike strings. Strings are the ones that don't change. So if I look at A, it's now different. But if I look at B, it's different also. So this kind of shows how they were just pointing to the one thing. If you want to make mostly just having the one list or whatever it is and having pointers sort of sprinkled through your program all pointing, sort of I could say sharing that data structure, for the most part, that's just totally fine. You shouldn't a priori try and block that out. I will show you how to make a copy, just if you wanted to. The way you make a copy, or actually I'll set B to be a copy of A, is the Pythonic way is use slice syntax. So if you say square bracket colon square bracket, that's the kind of Pythonic way of saying, well, here's a linear collection of things. Please make a copy of it. So now B really is a copy. So if I changed A, then B wouldn't change. Yeah, a question over here?
So the question was, if you, before you made a copy, if you made a change to B and also changed A.
Yeah, so the question is, so before I made a copy, if I changed B, would it reflect an A? Yes. So there's this one list in memory. They're both pointing to it. They're literally sharing it. Now, and I'm getting some funny looks. As a practical matter for your Python programs, this is just not a problem. It's just fine. In C++ or in C, you would want to make copies mainly because of the memory management, like trying to know when to free, when to reclaim the memory. But Python, like any reasonable modern language, has a garbage collector. It just takes care of the memory collection. And so as a result, this need to make copies just kind of goes away. Or when I found transitioning from C++ languages to Python, I found I was making a lot fewer copies. Like the need to do that had just gone away. So I guess what I'm saying is like you may have an instinct to make copies, but I'd say attempt to keep in check. Like you'll find you can just not make copies, and most stuff's just going to work fine. All right. So let's see. We got the square bracket, the length, the let's see. What are A and B these days? Oh, they're the same. The equals does comparisons, just like the string. So you have two lists. It actually follows the lists and checks piece by piece if they're the same. So as before, it does a kind of an intuitive notion of checking. Now, what's the other thing we did lists, right? Or with strings, it was a little complicated, was slices. That works with lists as well. So here I've got this list. If I say a, I don't know what, 1:3 or whatever, I can pull a slice out of a list. So for example, maybe the most common case is like if I want to talk about a list except for without the rightmost element. So I'll wait till we get to the exercises. But yeah, you've got this very concise syntax for kind of talking about subparts of a list. All right, so let me show you the main syntax for this thing. So a very common thing to do, and actually I'm going to, I'll write it over here in nice big letters. A very common thing to do is to loop over a list. And so for example, in C, or right, you've maybe written that loop where you say, for I equals 0, I less than something. And in Python, it would be very rare to do that. There's just a built-in for each construct that just loops over a list. And it's very commonly used, which is why I'm going to. If I actually walk over here and write it out, you figure it must be pretty common. All right, so the first word is you begin with for. And then just pick whatever variable name you'd like. So I'll just sort of underline that list. And then you have the word in. And then you have whatever the list is, and then a colon. And then you just do whatever it is you wanted to do for each element in the list. So for example, I might say print var or whatever. So this is just a built-in way of looping over a list and doing something for each one. So for example, now here I've got a, so I might say for num in a colon. Now here I'm going to write it all in one line, just because I'm in the interpreter. The Google style guide, the more correct thing would be to have a colon and then go to the next line. But it turns out you can just crunch it onto one line, as I'm doing here. So if I say for num in a print num, then what that's going to do, the little dot, dot, dot there is just an artifact of the interpreter, just to let me know there's more output coming, so you can ignore that. So really what that did is it just looped over the list. And once for each element, it's going to run this body of code. And each time through, that value num is just going to be one element from the list. So this is it's the very common case. You just want to loop over the thing. It's sort of a for each. Yeah, question back here.
How does it know that num results in those numbers?
Well, so what it's doing, so the question is, how does it know that num results in those numbers? What it's doing is num is just a variable name just chosen by me. It could have been anything. And what it does in the loop, essentially what it's doing inside the loop is like num is equal to whatever, kind of like what the next value is. It assigns it into num, just like a variable. And then after that, then it runs whatever little bit of code I have. And then it loops around and it does the next one. So in other languages, it's similar to the idea of an iterator. So this is, for the exercises, this will come up a lot. The idea that you have a list of a bunch of things and you kind of want to do something for each one, that's a common case. And this is certainly the syntax you should use for that. There is a related syntax. So this is the first one. The second one is very simple, which is just you have some value, and you want to check if it is in a list. And you can imagine. I'm sorry, is this too low down? You guys can't see. Sorry, I'll write it up above. Here, we'll put it up here. 2. Who stuck this here? Aha. All right. If you want to check if a value is in a list, you can write it this way. You just put whatever the value is, and then the word in. Just the in by itself, and then whatever the list is. So it's very short. So if you've got, this works for lists. It actually works for a lot of things. Just in Python is this built-in way that you've got some composite data structure, and you want to tell, is this thing in here? So what's a? So for example, I could just write 2 in a. And that's just going to go over a, figure it out somehow. Or what's something, I could just say a 14 in a. There's the false. So this is another one of these sort of higher in the food chain things. You might have an instinct, oh, I want to see if this is in here. Oh, well, I'm going to write a for loop, and I guess I'll loop through, and I'll compare each one with equals, equals, or whatever. You have to like, no. In Python, it's just built in. You just say, look, is this in there? It works for actually a lot of data structures. And in the hash table case, it's actually quite efficient. It does something smart, depending on what data structure you have. So you should not worry about doing something weird there. So along with slices, you should just, as I read over there, you should just go ahead and memorize those. Those two syntactic constructs, very common. You should just know those. And of course, my examples later on. This will appear all sorts of times. All right, so let me show you, just as with the string, we had methods like dot lower and dot replace and dot find, whatever. The list is the same way. It's got all sorts of built-in stuff. I'm just going to show you a couple. One is there's an append. And you can just guess what that does. Just puts it on the end there. One important thing about append is that it does not return a new list. It returns the special value none, which I know you saw in the starter code a little bit. None, uppercase N, I'll just type here, is sort of the null value. It means like nothing. So a.append returns nothing. What it does is it modifies the list. So it does not, it would be wrong to write this, a equals a.append of something. Here, I'll say, well, I have to say, no. I mean, there is this form of the world where, I mean, some other language, maybe that would work, but in Python, that just happens to not work at all. And it's because append does not return anything, it modifies the list in place. And that's, I've absolutely made that error myself. It's just there's these two different paradigms they could have chosen, and they chose the one where that doesn't work. Alrighty. Also, there's it's kind of the reverse of append. There's pop, and so if I this is by position. So if I say pop 0, what that's going to do is it sort of pops off the 0th element and returns it to me, and it modifies the list. So it kind of removes it from the list and sends it to you. So if you want to kind of remove an element and just kind of get it out of there, then pop is sort of handy. And then you should look at the docs. Yes, there are dozens of built-in list methods for all sorts of common stuff. And if you have a problem involving manipulating a list, searching it or replacing it or whatever, yeah, you should go find the built-in ones. There is a particular case, though, that I want to show you, and that is, well, actually, I'm sorry. There's one other one I'm going to show you, which is something I haven't talked about so far. So here is A. There's I guess this is an operator called del. And what delete. And what delete does, obviously it deletes, but in particular you can use it on a variable. So if I say del A, what that does is it kind of removes the definition of A from my local scope. Whereas when I had assigned A to 6 or whatever, that put it in there. So now, after that, if I try and use A, it's like, oh, that's not defined. So it's kind of the reverse of the direction I showed before. It happens that del also works on lists. So if I say A is equal to 1, 2, 3, and let's say if I can say, if I say A square bracket 1, that's the 2, right? So it turns out you can use a del to actually reach into a list. So if I say del of A square bracket 1, that kind of deletes it out of the middle of the list, but now the list actually shrinks. So that's, I've showed you how to add, okay, showed you pop. Well, so del is another way that you can sort of fiddle in there. Yeah, question over here.
So if you've assigned A to B, for instance, without copying it, but actually pointing to
So this is one of these cases where I should just do it in the interpreter. Right. OK, so let's say B is something, like it's 12. Right. And I say A equals B.
Right. And then you del A.
OK, yeah, so if I del A,
B still B.
Then B is still fine. Okay. All right. The del A, what it's done, it's just kind of removes its that. I mean, it's sort of like when I had A and B pointing to the list, right? That's like, well, the list is still there. Deleting A, I'm deleting the idea of A, but whatever it pointed to, something else might have been pointing to it as well. Now with the 12, my use of the word point there is a little inaccurate, but the basic pattern holds. Alrighty. So the most interesting thing with lists I want to show you is sorting. So there's this old way of doing sorting where there's actually a dot sort method on the list, and I want you to not use that one. I'm going to show you this newer, cooler way that it's just better in every way. And you could, all those dinosaurs who are using dot sort, you can just like look down on. All right, so what I'm going to do, well, first I'll just show you the most basic case. So I'll set A equal to, 4216. So the simplest way to do sorting is there's a function called sorted. And you can feed a list into sorted. And what it does is it makes a new list, and it sorts it. Sorts it into increasing order. Now, so in this case, when I call sorted on A, it's making this new list, and then it's sorting it. In this case, we're getting a numeric sort. In reality, what's going on is it's the comparison in Python depends on the type of thing being compared. And in this case, it's a list of ints. And so when it gets down to comparing one int to another, it sees like, oh, this is 2 ints, so I should do a numeric comparison. If instead I had a list of strings, it would have gotten down to the comparison. It would have seen, oh, I have 2 strings, and so it would have done a textual comparison. Again, it has that sort of Python quality of like at the last possible second, it sees whatever the 2 types are, and it does something appropriate in that case. So one of the nice things about sorted, and actually I'll pull up the help page for sorted. Remember help? So if I say help of sorted, it's pretty terse here. It says sorted of an iterable. So this actually works for a list. You can actually feed into sorted an iterator or some other things that kind of are capable of producing lists, although they are not themselves lists. You can feed those into sorted too. It just works with all those. Anything that kind of looks like a sequence. So the syntax here refers to optional named arguments. And so this built-in, like, yeah, you can just not specify CMP or key or reverse. But if you do specify them, then you can sort of give it this extra argument. So this is a nice quality in Python. So in this case, I had sorted of A is that way. I could also say sorted of A, comma, and then one of the optional arguments is called reverse. I mean, I had to go look up and see that was the name. But I can see the name is reverse. And if I pass true for that, then it still sorts them, but I just get it the backwards way. So that's a very common problem, right? Is you just want it sorted the other way, and so that's just built in. Yeah, question?
I just did the test to see whether A gets assigned a sorted list or it keeps the old definition, and it keeps the old definition.
Yeah, so sorted makes a copy. It makes a new one and sorts that.
So can we assign it to a new?
Yeah. So for example, well, so here's A is unchanged, right? Yeah. And here's sorted of A. What I could do, this is what you're suggesting, is I could say A is equal to sorted of A. Like, yeah, if I don't care to keep the original one, that's fine. So now it's just sorted. So you have whereas if it overrode it, you wouldn't even have a choice, right? So it's this way, you get to pick. Alrighty. So let me show you. So that's just like basic sorting. So now I want to show you, this is a little more sophisticated, but how to do custom sorting in Python. And the Python syntax, the Python structure for this, I think, is really nice. But it's going to be a little more complicated. All right, so I'm going to set up my case so it's exactly the same as the one in the handout. All right, so here I'm going to have some strings. So if I say sorted of A here, they're strings. By default, what I get is textual sort. Now, the problem I want to consider is, for custom sorting, right, you want to sort some other way, not just textually. The case I want to consider is, well, suppose I want to sort these by length. Right? I want the D first, and then the B's, and then the C's. Right? I want kind of increasing order by length, just as an example. How might I do that? Well, the old way to specify custom sorting in a lot of languages is that you write what's called a 2-argument comparator. You provide some function that takes 2 arguments and compares those 2 and returns either a negative number or 0 or a positive number, depending on how you wish for those to be ordered. And then you feed that into the sorting function, and it uses it. Anyway, that is a classic technique, the 2-argument comparator technique. But it's a little messy. It's a little difficult to describe. It's just not that great. So Python, we're just not going to do it that way. I'm going to show you a different way. And the idea is, here's a piece of art in the handout. So in this case, at the top, I've got my original list. And I've got this idea that what I want to do is I want to sort by the length. So the way it's going to work in Python is we are going to provide a function of 1 argument. This is called the key function. And this function of 1 argument, then what the system is going to do is it's going to run it over our original list. And for each element in the original list, it's going to call the function of 1 argument, and it's going to get a single value. And it's going to build up a list of those new values. So I'm going to kind of walk over here, kind of point at my drawing. So here at the top, we've got my original list. And I want to imagine the function of 1 argument that I'm going to use in this case is the len function. We've been using it all along, right? And len, when you call it on a string, it returns the length of that string. So I'm going to give it, I'll show you the syntax, but I'm going to say, hey, use len as the kind of key function in this case. So it's going to call len, 5 times. And it's going to just get these numbers, right? 3 for the string length 3, 4 for the string length 4. It just gets this kind of shadow list of new values. So now here's where the magic happens. What the sorting is going to do, when I call sorted, I specify a key function. It's going to make this shadow list, and then it's going to sort the shadow list. So the 1 is going to come first, right, and then the 2, whatever. It figures that out, and I got to make this hand wavy motion. So it's kind of like sorting motion, but then it applies it to the original list. It actually shifts around the original elements. And so the result is, then I get at the bottom. I get the original elements, but sorted according to the values of this shadow list. Now, it's a little hard, it's a bit much to follow, but I'll tell you, in my experience, this is a much more convenient way to do custom sorting. But you just have to sort of get your brain around this idea of projecting out the shadow list. So before I take questions, let me just demo that working. Show you what that looks like, and then we can work on some other examples. All right, so there's A. And here's len. This is like a function. It's a lot like a function. So what I'm going to say is what I want is sorted of A, and then I'm going to give this optional argument called key equals, and then I'm going to specify a function to use. In this case, I'm just going to say, yeah, use len. So if I do that, then it's under the hood, it's kind of projecting out that list. Now let me do a second example. And I'm going to change my list a little bit. Let's change A1 to be AAAZ. I'm going to mix my problem up a little bit here. Let's say, how do I want to sort this by the last character in each string. I want to ignore all the other characters. This can be this is the sort of problem. This is a custom sort that you might solve with a key equals function. And I'm going to do it with a def, just like we've done. So I'm going to say def last of a string. And I'm going to do this all in one line, which is not the normal, but because I'm in the interpreter here. So say def last of s. I'm going to say return, what is that, s of -1. So I'll say, OK, now last is fine. So now if I say last just on its own, I'm like, oh, well, that points to a function. Just like if I say len, OK, well, yeah, that's a function. I mean, one's built in and one's I just made, but it's still going to work. All right, so the last function, you give it a string, and it just returns that last character. So now if I say sorted of, so now I'll remind you what A is. A is that. So now if I say sorted of A, key equals just the thing I just defined, last, then check it out. So now I've done custom sorting. And in this case, what it's doing in the shadow list is it's just pulling out whatever the last, the -1, whatever the last character is, and sorting by that. So there's a couple examples of custom sorting. Yeah, question?
So if the last element in A was DD, would it, or that's probably, yeah, if it was DD, would it double sort, like do the first sort by number of characters, and then within, if there were two?
I see, yeah. So I'm going to answer a slightly different question. So I mean, there's this idea of, well, what if I want to sort by one thing, and then I want to sort by something else? You know what, I can answer that more effectively when I've covered one more data structure. There is a way of doing that, but I'd like to just hold off on it. And it's a very reasonable question.
So would it just be random if you didn't use that extra thing you're going to show?
I don't think it would have worked the way you want, but what I prefer to do, I want to save time and show you the way that does work. And then then we can talk about it, OK? I'm sorry, that's very unsatisfying, but there's this other data structure we really need for this. Okay. All right, so I understand. I think the sorted thing is one of the more difficult things to kind of get your head around. Yeah, predictably, the exercises have like a bunch of custom sorts, and it's a very powerful technique. So I'd say hold off on that, and then I do have this beautiful art in the handout to try and follow that. So just hold on with that. On the next set of exercises, will be pretty soon. You'll get a chance to play with that. All right. So let me show you just a couple other things with the list. So one, I'll stick with A just as these strings. One fairly common thing to do once you've got your program and you want to now produce your final output is you want to make a string out of a list. And so like one thing you might do is maybe loop through this list, right? I could type for s in A colon and kind of print each element or something. It turns out that's OK, but there's a built-in that just takes a list and sort of concatenates or whatever all the parts of it together just in one step. And so that's such a common operation, it's nice to know. So for example, if I were to say, so this is called dot join. So if I were to say colon dot join of A, what it does is it just puts it all together in one string just in one step. And so it's a little unintuitive, but actually the case I use most often is \n. Like I say new line dot join, and then really I've now got one per line, but just all in one step. And then I could just print that in one step, or write it to a file or whatever. So that is a handy one to know. I'll switch back to the colon one. So going the other direction, there's also a split. So actually here, I'll say B is equal to that. So now B is the string I'll put together. If I say colon dot split on B, oops. Was that wrong? Oh, I'm sorry. That's the other way. Sorry, B dot split on the colon. So you have a string, you call dot split, and you say, here's essentially the delimiter. Then it kind of explodes it out, so you can recover the original list. So split. I mean, these are not really intellectually deep, but it just happens to be a common case. So those are handy to know. Oh, I should mention, those are not regular expressions. Those are just substrings. We'll do regular expressions tomorrow. Yeah, question.
Did you talk about something really simple, which is like, what if you're going through a list of data and you're making a list? I mean, here you're just defining this, but
yeah. Here, so let's do a little example like that. Yeah. So the question is, how do you kind of make a list? Yeah. So one pattern that shows up in the exercises, like let's say I've got A here, and I want to loop through this, and I want to pick out some of them and put them in some other list. A pattern might be like this, where I'll say a result is equal to the empty list. And then I'll say something like for S in A colon, and now I'm going to I want to add some of them to the results or whatever. The way you would do that, I'll just add them all in this case. But I'm going to loop through, and I want to put some of this. I would just use append. So I'd say result dot append of S in this case. So now if I look at result, I mean essentially what I've done is I've just copied all the elements over. So in terms of that is a common pattern. You start with empty list, and you kind of put some stuff in it.
I guess I meant if, like, let's say you're going through a bunch of documents or data or whatever.
Yeah.
And you don't have any lists yet, and you're starting your for loop.
Yeah. All right. So the question is, what if you have documents? Or I mean, essentially, what you're getting at is kind of realistic. And the trick is, I'm going to show you how to open files and read text out of it. And then I think at that moment I will answer this question. But yeah, thus far I'm just doing lists a little bit. I haven't gotten to that yet. Alrighty. So the last thing I'll show you is just sort of for completeness. I haven't showed you like a traditional for loop like I equals 0, 1, 2, like in C or JavaScript, you might do that all the time. Mostly the ones I've showed you, these techniques just cover it. However, I will show you how, if you want to count over a bunch of numbers, the way to do that is there's a function called range. And what range does is it's sort of on, if I say range 20, it sort of on the fly appears to build this list, starting at 0 and running up to, but not including that number. So if you wanted to count from 0 to 19, you could say for I in, and then call range to kind of on the fly make this list appear. And so that would be a way. Now there's a little bit of a difference between Python 2.4 and Python 3. Whether is that list really created in memory or is it kind of fake created? The more modern versions just fake create it, or which saves memory. So you should not worry about that efficiency detail because the more modern versions are just all over it. Now I've showed you just the most simple case of calling range, where you give it one argument. But in fact, you can specify the starting number and the end number, and should it go by 5s, or all those kind of permutations range supports when you give it more optional arguments. And so if you wanted to generate a series of numbers, you could. That would be the way to do it. There's also a while loop, which I'm just not even going to demonstrate. But yeah, it works like while loops in other languages. The most common case, though, is the one I've showed you, just the for loop to loop over a collection. The last thing I'll have to say about the for loop is that it does have this constraint, which is when you are looping over a list, you cannot modify that list in a way which changes its length or structure. So you can't add an element. It kind of makes sense. If you add an element in the loop, like you could kind of get this weird infinite structure. So do not modify while iterating over. Interestingly, Java has that same constraint, sort of based on. There's an implementation reality underneath there. Alrighty, so we're almost ready for another exercise. The last thing I want to show you is the tuple. So I showed you strings was surrounded by quotes, lists surrounded by curly braces. The tuple is actually, it's a modest little data structure, and it looks like this. Tuple is put in parentheses, and it has commas inside to separate the elements. So a tuple, now a list can grow and shrink, right? It can start as length 0, and I can append, put stuff in there, delete, whatever. The tuple is fixed size. You create it length 3, it's length 3 forever. In fact, it's immutable. You just can't change it. So the tuple is good if you have some fixed number of items. Like let's say you want to store an x, y, z coordinate in 3-dimensional space. Right? There's never going to be a fourth number. You know it's these 3. I want to lock them together. Tuples are good for that. Or let's say you have a URL and a score. And it's these 2 things. It's like, I want these 2 things to go together. In Python, you can put those in a tuple length 2 and then store that in a list or return it from a function or whatever. So the tuple is the kind of anonymous way of taking a fixed number of things and just kind of locking them together so that you can pass them around or store them or whatever. And in the later exercise, you'll see some examples of this. So I'll assign A to this tuple, I guess. And then kind of like you could guess, I make this claim that Python's all consistent. So how do you suppose you tell the length of a tuple? Of course, it's len, right? And how do you pick an element out? Yeah, it's square bracket. So all that stuff, list, strings, pretty much works for tuples as well. The one difference is the tuple is immutable. So if I say a square bracket 0 equals 13, I try and assign into it, then that's going to fail. Right? So the tuple can't be changed. Once you create it, it's like a string. So tuples and strings, immutable. Lists, mutable. So there was a question earlier about sorting. And it turns out if you want to sort by one thing and then sort by another thing, the best way to do that is with tuples. And so I think I could do a short example here. So I'll say 1, comma A, comma. So I'm making a list of tuples here. Oops, OK, let's make that B. And then here we'll make this 2, comma A. So the way it's going to work is if you sort tuples, just the natural under-the-hood sorting, what it does is it first compares the first elements of the tuples. And if they're different, it just sorts by that. But if those elements are the same, then it goes to the next one. So here, now I need to make this, now I need to say 1A. All right, so what I've made is a list of tuples. And to show this off, I think if I do sorted on that, where the first numbers are the same, it goes to the second. Right? So in the 2, 1 cases, then it's sorted by the A, B, and then this one is last. So this is a little bit of a detail. It's not something I hadn't planned on mentioning this. But for the question back here, if you wanted to sort on one thing and then sort by something else, what you could do is write your key function to return a tuple. And then by whatever you put in that tuple, you could get the behavior you want. Put the thing you want to sort on first as the first thing, and then a comma and whatever the second thing is, and then it'll just automatically go to the second thing if the first thing is the same. And that's just built-in Python sorting. Like it gets how to sort tuples that way. Alrighty. So one other thing I have to show you with tuples, this is kind of a, dare I say, kind of a Perl. I think of it as sort of a Perl feature, is that if you say x comma y, there's the special thing with assignment and variables. If you say x comma y in a tuple equals 1 comma 2, what it does is kind of a parallel assignment. So now x is 1 and y is 2. Not super common thing to use, but it does show up now and then. OK, now that's all. There's some other stuff that I'll show you later about that. Alrighty, so what we've seen really at this point, let's take in, is lists, how to loop over them, and a dot append and whatever, and sorting, and a little bit about tuples. So what I would like you to do is take a look at, there's an exercise, I'm sorry, a question?
Yeah, does slicing work with tuples as well?
Yeah, slicing works with tuples. Yeah, I like you think. So what I'd like you to do is take a look at the exercise list1.py. This is going to involve doing basic stuff with lists and also a little bit of custom sorting. As before, If you're just so unbelievably fast that you finish those, then there's a list2.py. But mostly, I'm just hoping people can get at least some of the problems done in list1.py. And what I'd like you to do is work on that. I'm going to say for half an hour. So I'm going to pull you guys back here at 2:20. I'll do a little more lecturing, and then we'll have a significantly bigger exercise to finish out the afternoon. OK, so off with the coding.